All right, so in section 4, instead of doing the proportions or the means, we're looking at the standard deviation. So I wanted to look at a couple of them, number 2 and number 5. And so first you have to understand what degrees of freedom means. We have to use a different table, just like with means. If it was a small sample size and we didn't know the population standard deviation, we had to use the t-distribution. So with variance and standard deviations, we have to use this chi-squared table, or we use StatCrunch. And they talk about degrees of freedom. Well, degrees of freedom, all that is whatever your sample size is minus 1. So that's why that first one's 25. If we are actually using the table to find critical values, we have, just like we have a lower limit and upper limit, we kind of have that for the chi-squared as well. So if I want to find this lower limit of the chi-squared for a 95% confidence, I could click on the table. Alright, so we were looking at a degrees of freedom of 25. Alright, and then if we were 95% confident, we kind of have to think of what the picture would look like. Let's see if I can get a decent picture with StatCrunch of what's going on here. So if I go to calculators and I go to a chi-squared, I know my degrees of freedom are 25. And I know the area in between I want to be 0.95. Oh, and it'll tell it to me, right? So I have 13.12 to 40.65. This will be a easier way to probably do it. But that means 95% within here, and I have 2.5% over here, and 2.5% over here. So that's what the picture is telling us. But let's go verify these numbers of 13.1197 and 40.6465. So using that table that they provide us here. So again, that means this is the area to the right of the critical value. So if I have 2.5% in that very left tail, that means I'm looking at 0.975 to the right of that. If I'm looking for the right one, I'm looking at 0.025 to the right. So again, this would be my left one, this would be my right one. But I need to get to the right degrees of freedom. So there's that 13.12 that we got a second ago. Ours was 13.1197. And then over here, 40.646. That's the other number that we got. So you can use the table and that'll be fine. But again, StatCrunch does a bang up job on this. The right value then is 40.646. So the confidence interval estimate of sigma is, so now we're going to figure out the confidence. So again, we know we have a 95% confidence, we have n equals 26, so our degrees of freedom is 25, and our sample standard deviation is 65.4. So when we're doing this one in StatCrunch, I'm going to tell us that we have to be careful. So we're doing variance stats. So we've done proportion stats in 7.2. We've done z-stat or t-stat in 7.3, and we'll do variance stat in 7.4. And again, we have a summary of the data. If we actually had the data, we would use data. Now it's asking for variance. So we weren't given variance. We were given S. So what we have to do is take our 65.4 and square it, because that's how we get variance. So our sample variance is 4277.16. Our sample size was 26. We're doing a 95% confidence interval. So we get these values. Now again, let's notice that this is for variance. We have a lower limit of 26, 30, 70, 82. 26, 30.70, 82. So let's take the square root of that answer. So I have 51.2904. And then I'm going to do the same thing again for my upper limit. So 8150.2501. 90.2787. Again, we did this because this sound variance, but the homework question is asking for sigma, so just the population standard deviation. So 51.3 and 90.3. So again, what we're saying is that we are 95% confident that the true population proportion, true population standard deviation is in between 51.3 and 90.3. And again, we're not 100% confident, we are 95% confident. Another one that we're going to look at is number 5. On number 5, we were given data. All right, so we're again asked to estimate the confidence interval for the population standard deviation. So we're going to do the same thing as we did before. It's a 90% confidence interval, right? Except I'm going to open my data in StatCrunch. So same thing as before, stat, variance statistics, one sample, and we're going to do it with the data this time. So my data is in var1. We wanted to be, I think it was 90% confident, and we hit compute. Again, these are our variances, so for us to figure out the population standard deviation, we would take the square root of this number and this number.